Hi, this is Mrs. Ward, and I'm going to try and explain the binomial theorem today, which is in section 9.5. We're going to use the binomial theorem to calculate binomial coefficients. We're going to use Pascal's triangle to calculate binomial coefficients, and we're going to use binomial coefficients to write and expand binomials. So the first thing we have to do is I just took a binomial, which means it has two terms. I took my x plus y and I raised it to various powers. And there's some things that you should notice when you're looking at this. There's powers that definitely occur. And so I've highlighted some of those patterns. First of all, there are n plus 1 terms. When I raise something to the 0 power, I have 1 term. When I raise something to the first power, I have 2 terms. When I raise something to the 5th power, if I'm counting there, I see if I'm raising something to the 5th power, I actually have 1, 2, 3, 4, 5, 6 terms. So there's always one more term than in that first degree that I'm raising it to. I also know that they're symmetrical. So if I focus on this row here, when I have x plus y raised to the 5th power, it's symmetrical where I notice that my exponent goes 5, 4, 3, 2, 1. That's my x, and then it's not here. And why my x is going down, my y isn't here, and it's the first, second, third, fourth, and fifth. So it starts to increase. At any point when I add the exponents, like here I have they add up to 1 because y isn't there. 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5. They always add up to the power that I raise the binomial to. There's something else that I noticed about my expansion. If I look at the coefficients, my coefficients go 1, 5, 10, 10, 5, 1. If I look at the line above, it goes 1, 4, 6, 4, 6. So it's still symmetrical. I just have that oddball term in the middle because there are only 5 terms when I raise something to the 4th power. And then the last thing is I explained all this, so we did that already. So we're now moving on. The binomial theorem says that you can use the combination to know the coefficient. So if you remember from last year, I believe it was Flip Mastery Learning that you did the combination. So when you do that, you're using factorial. So if I had combination 6 choose 2, I would do 6 factorial over 2 factorial, and then I would take 6 minus 2 and do 4 factorial, and then I would simplify that. So that's how I do the combination. The reason why, so we can practice these combinations, and we're just going to do a few. So if I do combination 9 choose 2, I will do 9 factorial over 2 factorial. 9 minus 2 is 7 factorial. If I remember simplifying these from the last section, I would rewrite the top as 9 times 8 times 7 factorial. The denominator is 7 factorial and then 2 times 1. These 7 factorials would simplify, the 2 and the 8 can simplify, and my final answer would be 36. If I have one that has 0, someone skips this one that has 0, I'm going to have 8 factorial over 0 factorial, and then 8 minus 0 is 8 factorial. So what's going to happen is the 8 factorials are going to simplify, and that's just going to be 1. And how I use these when I'm doing my binomial coefficient is this would be if I had x plus y raised to the 10th power, and I want that. So this tells me the power that I'm raising it to. This tells me the term that I'm using. So this is my power. That's my term. And I'm only finding the coefficient of the 3rd term. That's all I'm doing when I use a combination. So I'm going to do 10. And 3 factorial, 10 minus 3 is 7 factorial, so 10 times 9 times 8, 7 factorial over 7 factorial, 3 times 2 times 1. The 7 factorials will simplify, the 3 and the 9 can simplify, the 8 and the 2 can simplify, and I'd end up with a coefficient of 120. So what I mean by coefficient is the number that would appear in front of the, because on the 3rd term, it would be x to the, so I'd start with x to the 10th, x to the 9th, sorry, x to the 8th. So that would be my 3rd term. That would be my 3rd term. X would be raised to the 8th power. So if x is raised to the 8th power, y has to be raised to the 2nd power because those two would be added together, and this is if they wanted to find the actual term, and then the coefficient would be 120. So this is the 3rd term, They didn't ask for that, they just asked for this coefficient, so that's all you have to do. So when they're asking for the coefficient, you just need to know that this is raising it to the 11th power, and this is the 10th term. And just so you don't get confused, remember, if you're raising it to the 11th power, you actually have 12 terms. Just making sure you remember that. Okay, we're skipping ahead, and we're going to talk about Pascal's triangle, because I think Pascal's triangle is a much more efficient way of finding the coefficient when I'm expanding the binomial. So Pascal's triangle, kind of like the holiday season, reminds me of a little Christmas tree. I start off with 1, and then I have to start off with 1 again and end with a 1. And then for the second row, which is really the third row, but we call it the second row, I start off with a 1, I add these two together, and I end up with a 2, and then I end with a 1. So to write the next row, I'm going to start with a 1, add these two together and get 3, add 2 plus 1 and get 3, end with a 1. So I always start with a 1, always end with a 1. So now I'm going to do the next row, because I'm going to do quite a few rows, because it's so much fun. I'm going to start with a 1, add 3 plus 1 and get 4, 3 plus 3 and get 6, 3 plus 1 and get 4, and end with a 1. I'm never going to ask you to memorize Pascal's triangle, but you should be able to figure out Pascal's triangle. Doing the next row, start with a 1, add the 4 plus 1 and get 5, 4 plus 6 and get 10, 6 plus 4 and get 10, 4 plus 1 and get 5, and then I end with a 1. And I'm going to stop here for a second, and I'm going to go back to the very first page. And remember when we highlighted this first row that we were talking about, when we raised something to the 5th power? Look at those coefficients, the 1, the 5, the 10, the 10, the 5, and the 1. Going back to Pascal's triangle, I noticed that those are the same numbers, the 1, the 5, the 10, the 10, the 5, and the 1. So when I have this, this is actually the coefficients of taking x plus y to the 5th power. The second number tells me what power I'm raising it to, and those would be my coefficient. So if I had a simple one, and example number 4 on your sheet, and I skipped quite a few examples here, example number 1 on your sheet tells you that you are going to raise it to the 4th power. So I'm going to go back to Pascal's triangle, and whoopsie, went too far, and I'm going to look at this 1, 4, 6, 4, 1. And we're going to make this one probably a lot harder than it has to be. So I'm going to write this coefficients across the top of a box that I'm going to make. And then the second thing, my first term is going to be x, and my second term is going to be 1. Well, in the first term, remember, this starts at the highest power. So this x is actually raised to the 4th power. And then the x power goes down by 1 power each time. So if we're having a good day, which I think we are, x to the 3rd, x squared, x, and then x raised to the 0th power would just be 1. So those are going to be what my first term looks like, that x to the 4th, x to the 3rd, x squared, and x. Then I'm going to take 1. Well, 1 raised to 0 power is going to be 1. Then 1 raised to the 1st power is going to be 1. 1 squared is going to be 1. 1, 1. So then they're going to stay the same. So when I find my final answers, it's like I multiply 1 times x to the 4th times 1, I get x to the 4th, plus 4 times x to the 3rd times 1, 4x to the 3rd, plus 6 times x squared times 1, 6x squared, plus 4 times x, 4x, and then 1 times 1 times 1 is 1. So this is equal to x plus 1 to the 4th power. So gone are the days of taking the binomial x plus 1 times x plus 1 times x plus 1 times x plus 1 and foiling it all out. We're just going to use this pattern. So let's look at one that's a little bit more exciting. I guess I'm skipping ahead. Probably shouldn't do that, but I'm going to. So we're going to do example 5. We are going to do B, because B has a little bit more fun things going on. So I'm raising it to the 4th power. So going back to Pascal's triangle, if I didn't remember Pascal's triangle, it's very simple to create Pascal's triangle. I am going to use this row here. So I'm going to do 1, 4, 6, 4, and 1. That's the first row of my box. The second row of my box, put some columns in here, is going to be 3x. So in the first box, I'm going to take 3x, write this small, 3x to the fourth. But I'm raising the whole thing to the fourth power. So I have to raise the 3 to the fourth power and the x to the fourth power. So I'm going to end up with 81x to the fourth. Then the next box would have this 3x raised to the third power, which will end up being 27x to the third. And I'm going to keep that pattern going. And I'm trying to, and then this final one would be 3x raised to the 0 power, which is just going to be 1. And I feel like I need to fill this in. Okay, that's the 3x. The next one, kind of tricky. It has that minus y or negative y. So I'm going to count it as negative y. So the first thing I'm going to do is I'm going to take this negative y and I'm going to raise it to the 0 power. Well, anything raised to 0 power is just 1. In the second box, remember, these powers increase by 1. So negative y raised to the first power will be negative y. Then I'm going to have negative y squared, which will end up being y squared. And it's going to be positive y squared, because negative times negative is positive. Then negative y to the third will end up being a negative y to the third. And then negative y to the fourth, well, again, I'm raising it to the even power, so it'll become positive. So this would be y to the fourth. What should happen when you, well, I'll explain that in a second. So now I'm going to multiply. And when I multiply, I'm going to have to make sure that I multiply the 1 times the 81 to the x to the fourth times the 1. And I'm going to get 81x to the fourth. The next column, I'm going to take 4 times 27x to the third times negative y. And I'm going to end up with a negative 27, whoopsie, I lied to you, 4 times that, 108. 108 x to the third y. Then I'm going to multiply again. 6 times 9x squared times y, and notice it's positive, so it's going to be positive 54x squared y squared. Multiplying again, there's my highlighter. 4 times 3 times negative y to the third, and that is going to end up being a negative 12x y to the third. And finally, the last column, I'm going to multiply 1 times y to the fourth. And when I do that, I end up with positive y to the fourth. Some things that I should look for. And this was, what did I start off with? 3x minus y. When I have, when the second term is negative, my sign should alternate. So I go positive, negative, positive, negative, positive. That should happen when the second one is raised to negative, raised to different powers. Then when I check any exponent, 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, 4. That's a good way to check to make sure that your exponents are enough, is that they should add up to this 4. So we'll do one more, example 6. Write the expansion of 3x squared. You're doing the same thing, except for now you have your second term is raised to the power, so you're going to have to be careful when you're raising the second power to the fifth power, the fourth power, and the third power. Still doing it the same way. This is to the fifth, so when I go to my Pascal's triangle and I copy down my coefficients, this time I'm going to copy down 1, 5, 10, 10, 5, and 1. That's from Pascal's triangle. Then I'm going to do 3 to my different powers. So I'm going to start with 3 to the fifth, which is 243, then 81, then 27, 9, 3, and 1. I didn't do that fast, sorry. And then x squared. So this first will be x squared raised to 0, which will just be 1. This will be x squared raised to the first, which is x squared. This is x squared raised to the second, which will be x to the fourth. X squared raised to the third, which will be x to the sixth. X squared raised to the fourth, which will be x to the eighth. And then finally, x squared raised to the fifth, which will be x to the 10th. Since I have this power in here, it's going to be 10 now. And so this going, the exponents aren't going to add up. They're also not going to add up because I don't have a variable there. So when I do this, I end up with 243 plus 405x squared plus 270x to the fourth plus 90x to the sixth plus 15x to the eighth plus x to the 10th. And that would be the expansion of 3 minus x squared raised to the fifth. Number 7, it wants you to give Number 7, it wants you to give the fifth term of a plus 2b raised to the, oh, you guys have to the 7th power, so we're going to get to the 7th power. So I'd have to do Pascal's triangle. Let's give myself more room. That's a 5. Okay, so 1, 7, 21, 35. So when I think of this, I can do Pascal's triangle and count 1, 2, 3, 4, 5, and know that my coefficient is 35. Or I could have done a combination, raising it to the 7th power. If I'm raising it to the 7th power, my fifth term would actually be 4, which is when you're not going to be able to tell within 35, but 35 matches, because this would be this first one would be a combination, raising it to the 7th power, choose 0. Then this is a combination, 7th power, choose 1, combination 7, 2, combination 7, 3. So this one is combination 7, 4. So the number of term, this R will be 1 less. So I could have done 7 factorial over 4 factorial, 7 minus 4, 3 factorial. 7 times 6 times 5 times 4 factorial over 3 times 2 times 1 times 4 factorial. Either way, I'm going to get the same answer. This is 6, 6, and I get 35. So either way, I get 35. So my coefficient is going to be 35. This A, if I'm finding the fifth term, will be raised to, well, I like to do the B first. This 2B would be raised to the 4th power because it starts off raised to 0. So it's always 1 less. And then I have to ask myself, what do I have at 4 to get 7? And you say 3. So then I'm going to have 35, A to the 3rd, 2 to the 4th, 2, 4, 8, 16, B to the 4th, multiply my coefficients, and then have A to the 3rd, B to the 4th. So this answer would be, if I check my calculator correctly, 560. That's what I get when I take 35 times 16, so 560. So that would be my fifth term, and I'm only going to find my fifth term. All right, I hope this helps. We'll talk about more in class, but I hope this helps, and have a great day.